Okay, just a quick video showing configuration of that setup that I was running. So really, we're just cascading, running on a differential here. This motor is running on a differential of about 10 volts because that's what the difference is between these two batteries. So this motor is running on that, and of course it's charging this battery, and then we're simply running this motor across these two batteries. There's a differential of this on roughly 12 volts across this motor, and then it's charging this battery. This battery is conventionally running this motor. It's just tied back to the ground, and it's running at roughly 15 volts, and I want to maintain 15 volts across this battery for various reasons, and I do that with a 75 ohm potentiometer. It's a heavy duty pot. So anyways, that I can regulate the voltage, and I want to maintain it, like I said, at 15 volts. Ideally, I want to maintain this one here at 30 volts. So I want these two batteries to be fully charged. Right now, I'm not concerned really about the voltage on this battery because I'm not putting anything back to it. I'm just taking from this battery. So with these motors free running across, let's just say a 12 volt battery, they draw about 2.8 amps each. So if you run, 3 of these, be close to, probably around 8 amps, 8.5 amps, something like that, to run them all free running. Now they are coupled together, and these are the motors themselves, just your generic fan motors, and they're coupled together with an O-ring. Now this O-ring is quite tight. I put it around all three, and obviously that just to run, and it basically acts as a load as well too. But anyways, that aside, when I couple them together and then run them, what happens is the amperage across this battery will drop. The battery voltage here will drop, and I believe this battery voltage will drop too, but let's just say it does. So this one drops, and of course this one drops. So in order to combat that, because I'm like when I couple them, I only am drawing 1 to 2 amps. It's probably 1.5 amps across this particular section for this motor. So what I want to do is I want to maintain, I want to stop this motor from drawing down this battery. I want to stop this motor from drawing down this battery. So what I'm going to have to do is apply more load across these two batteries, and I do that via 2 or 4 other motors. And I just have them free running, and they're about 1 amps or 0.9 amps, no load. They're not coupled to anything. So what I do is, you could basically take these out of the system, and take these 3 out of the system, leave this guy in here, load that shaft to get the desired amperage that is flowing, the desired amperage that would be flowing from this high potential to this lower potential, and charge this battery. That's why I want to maintain fully charged states in these batteries so that they basically run like an automotive battery charging system. That the alternator basically doesn't put out, or doesn't, the alternator puts out all the generated amperage and voltage to run the system in your vehicle, and the battery is basically just an accumulator there for backup. So yeah, so that's why, like I said, that's why I want to put a load on across this particular system so I can generate more amperage, because 1 to 2 amps is not enough to keep these batteries fully charged with these motors running. So yeah, we put a load on the across these batteries. I can load it by hand. I've drawn probably about 9 amps or better by gripping the shaft of the motor with paper towel between my fingers. I put a pretty decent load, and of course this battery goes up in charge, and so does this one when you do that. And when it goes up in voltage or charge, like this one becomes a stronger motor, so does this one, and this one pretty much probably would stay the same depending on the voltage across these two. If this one's climbing and this one is staying the same, then of course you're going to have a smaller differential here. So you'd only have, like if this was regulated at 30 volts and you had, let's say 36 volts, well, you only have 6 volts running on this motor. So this one here would be powering it, and if you had 30 and 15, there's 15 volts effectively across this motor, and of course 15 volts here. So these motors are 15 volt motors all of a sudden, and this one's only like I said, a 6 volt motor. So that's the reason why you can put some shaft energy on there, is that and not draw a lot of amps out of here. It's because of these motors powering this device here and over speeding it. So it's actually running like a DC motor will run at 10 volts at a certain RPM. Now if you increase the RPM mechanically, like we're doing here, then all of a sudden this thing becomes a generator, again reducing your amperage. So that's probably why we are seeing that the amperages don't line up on this complete system. The system appears to be using less amperage than what it should. And you could cascade, like I said, cascade out this stuff a lot farther. The sky's the limit, I guess, depending on how many motors you want to put in this type of configuration. But I think it's a real benefit to couple them. You could have 10 motors arranged in a circle, all coupled together via a belt or like a timing belt or what have you, or a chain and sprockets, and then you could have your generator in the center, and you could simply have all those 10 motors running your conventional generator or whatnot and producing real energy that you could use to charge back your initial power source, because remember, these are kept fully charged, so they shouldn't really need charging. And if they do sulfate, like automotive batteries do over the course of time, then just use your Bedini charger, or you could run pulse motors in here and then not have that issue. But how long does it take for an automotive battery to sulfate? If it's kept fully charged, it could take years before it would show up the effects of sulfation. But there's also a surface charge here on another topic. There's also, of course, once a battery gets charged at 15 volts, the difference from, let's say, 14 volts to 15 volts, it doesn't take a lot of extra amperage to be dumped into this battery to reach that 15 volts. So it's almost like free. You get a free, probably a volt or a volt and a half of energy to be used in here, because of the battery itself just climbs instantaneously, almost from 14 to 15 volts. Well, it's not instantaneously, but it takes a little bit of time, but not much. But anyways, that's it. This is a quick video showing, hopefully it explains a little bit what I'm doing and the way I'm thinking about it anyways. So thanks for watching.